Okay, so just to continue solving using power series, okay. So when you get a problem like this and you want to find a power series as a solution, you're always going to start with the basic power series where it's n to 0 to infinity c sub n x to the n. Now, if you notice, right here we have the derivative. So you're going to have to take first and second derivative and just use your properties. Remember that c is constant, and actually, remember when you take your derivative, that first constant will be 0, so you want to go to the next term would be at 1, so it's going to be c of n times x to the n minus 1, and then for y double prime, remember now we're going to start at 2, and it'll be c of n minus 1, and then x to the n minus 1, n minus 2, sorry. Alright, so you'll have that. Now plug everything into the differential. So y double prime will plug in, and minus x times y. Okay, once you get here, just do some algebra. All right, you could see that you kind of want to bring that inside, right? Add exponents. So I'm going to have, let's leave this the same for now. So this will be x to the n plus 1, and then that'll equal 0 that way. So now here we go back to 6.1 where we want to combine both of these together. We want to add these together, or in this case subtract these two series. But a couple things you want to do, you want to make sure you start at the same value. You want this to be x of k, sorry, x to the k. So I know in this situation I'm going to make k equal to n minus 2, and in this series I'm going to make k equal to n plus 1. The only issue is, remember to then plug in, right? If you're plugging in 2 in the first one, you're going to get 0, but if you plug in 0 into the second one, you get 1. So let's just plug 2 in so that we could start at 3, and if we start at 3, then both series will be starting at 1. So if I plug in 2 to the first series, I will get C2 C sub 2, right? And then that's plus, and now we can start at 3, everything else stays the same. Okay, now still using these two values, we can get n equal to k plus 2 in the first one, and n equal to k minus 1 in the second one. So now I'm just going to replace everywhere I see an n with that k plus 2. Also, I'm going to replace the starting value. So you can see here and here are going to change as well, because now if I plug in 3 into this equation and plug 0 into this one, both series will start at 1. So k equals 1, c sub n is k plus 2, so I'll have k plus 2 times k minus, so it's k plus 1, x to the k, that should always be the same, and then minus k equals 1 to infinity, c sub k minus 1, and x to the k equals 0. Okay. Now at this point, we want to like subtract these together, and then I'm going to factor that out, that x of k. So it'll look like this when you do that step. You'll have c sub k plus 2, k plus 2, k plus 1, minus c sub k minus 1, and then multiplied by x of k, and then that equals 0. So now the only thing different than that last example that I gave from 6.1 is you have this term out here. But what we want to do is when we're solving this for 0, we want to figure out, well, every term also has to equal 0. So in this case, we know C2 will always be 0. Because it's addition and you're having this sum equal 0, you know that first term has to also be 0. So in this case, C sub 2 will equal 0. Now in order to find k here, we could use what's inside. So you're setting this inside portion equal to 0. Okay, whenever you're solving these, always solve for the larger sub. So k sub, I always do that. Okay, so you have c sub k plus 2 is going to equal a positive c sub k minus 1 over k plus 2 and k plus 1. And this is for k to be 1. Now the way I know that it starts at 1 is always what you're starting your series at. So 1, 2, 3, dot, dot, dot. Alright, so always keep in mind, right, we know that c sub 2 is 0, and now when you start to plug in values, so let's say k equals 1, okay, when k equals 1, what we're doing is we're plugging k in for everything here. So I'm going to get c sub 3 equals c sub 0 over 2 times 3. Now I did it in a different order, just I like it in ascending order, so I plugged it in, but you can see where I'm getting that from. So when k is now 2, so c sub 4 is going to be c sub 1 over 3 times 4. K is 3, c sub 5 is going to be c sub 2, 4 times 5, but we know since c sub 2 is 0, this is just going to equal 0. When k is 4, you get c sub 6. And you can notice the pattern is going to continue. Now this step here, right, where you get c sub 3 over 5 times 6, we already know c sub 3 up here. So all I'm going to do is replace that and write it as 1 over, I got 2 times 3 times 5 times 6, and then c sub 0 that way. And then this just continues. So k is going to be 5, so c sub 7, c sub 4, 6 times 7, but again, here I have c sub 4, so it's 1 over 3 times 4 times 6 times 7, and then that's c1. K equal to 6, c sub 8, it's going to be c sub 5 over 7 times 8, but again, because c sub 5 is 0, this one is 0 as well. So let's just finish out a couple more. C sub 10, c sub 6 over 8 times 9, but we know c sub 6 was up there, so you get this messy 2 times 3 times 5 times 6 times 8 times 9, and that's C sub 0. So here we have when k is 8, you have C sub 10, C sub 7, 9 times 10, it's same idea, we're C sub 7, so it's 1 over 3 times 4 times 6 times 7 times 9 times 10, C sub 1, and if you notice the pattern, right, 2, 0, 2 more terms, 0, 2 more, this C of 11 when k is 9 will wind up being 0, because here you'll have C sub 8, and you could see C sub 8 is 0, even though you would have 10 times 11, but that's still 0. So, I mean, I did a bunch here. Sometimes it's not necessary to do so many, but now what we're going to do is put this together, okay? So, try to keep that in there. Okay, so when you're thinking of a power series, think about the terms in a power series. You have C sub 0 plus C sub 1 x plus C sub 2 x squared plus C sub 3 x cubed, and then this pattern continues, right? Now I know I went all the way up to C sub 11. Not always necessary if you notice the pattern, but you could see the idea. So what's going to happen here is I'm going to replace, if you notice what we have, don't forget that your C sub 2, right, up top is 0, but everything else is C sub 1 or C sub 0, right? You can see that. Everything is C sub 1 or C sub 0. So when you plug in, you'll have C sub 0 plus C sub 1 x plus, now C sub 2 is 0, but now we get C sub 3. So if I go up top, C sub 3 was C sub 0 over 2 times 3, and then you have your x cubed, plus C sub 1 over 3 times 4, x to the 4th, plus, now C sub 5 was 0. Whoa. Sorry about that, it froze. Okay. So C sub 5 was 0, plus, now C sub 6, we got C sub 0 over 2 times 3 times 5 times 6, and then that'll be x to the 6th, C sub 7 is 1, so C sub 1 over 3 times 4 times 6 times 7, x to the 7th, right? And then you get another 0, and it'll be C sub 0 over 2 times 3 times 5 times 6. And then this will be x to the 9th. And then the last one I'll put in there is the x to the 10th term. So 3, 4, 6, 7, 9, 10. So, I mean, you could see, like, pretty sloppy in the sense of the way it looks, but this would be your way you could set up a series. What I mean by that is, if we know that, go back to when we're finding solutions, we'll have a constant times y1 plus another constant times y2, right? Y sub 2. But we have that here because if you think about it, let's make C sub 0, right, with y1 and C sub 1 with y2. So that way, when you're writing your solution for y1, you're just looking at all your C sub 0 terms. So you have this term here, you'll have this term here, right? C sub 0 term, right? C sub 0 term, and so on. So what it'll look like is you don't need to worry about the c sub 0. You're kind of factoring that out. So you'll get a 1 for that first term plus x cubed over 2 times 3 plus x to the 6th over 2 times 3 times 5 times 6, and then plus x to the 9th over 2 times 3 times 5 times 6 times 8 times 9. And then this continues, and that would be your power series. Now, they don't ask you too much to write these. This one's a little confusing. If you go, like, say you're writing y1 as a power series, you would do 1 plus, and then you can write it as a power series, but it's very, I don't really like it, but it would be like x to the 3n over 2 times 3 times dot, and then have the little dots there, and you could have 3 k minus 1, right? Because like 5 would be like, if you plugged in 2, you would get 5, and then 3k would give you that 6. So that would be your power series for that. And it just works with, you know, I'm looking at exponents here. They're going by multiples of 3, and I'm doing the same thing with the denominator. Now, this is not usually asked too much to write it this way, but as long as you could get it to look like this, that's okay. Now, for y2, it's done the same way. So if I'm doing y2, instead of starting, let's do a different color. So you can see all the c sub 1 terms, right, are going to be what you're using there. So if I factor out that c sub 1, I'll just have x plus then x to the 4th over 3 times 4 plus x to the 7th over 3 times 4 times 6 times 7 plus x to the 10th, and then the same thing, 3 times 4 times 6 times 7 times 9 times 10. Okay, and then if you want to make this as a series, we could do this a similar series. So x plus n equals 1 to infinity. Oh, if you're using n, just stay consistent with the n. Try not to do that where I changed back to a k. Okay, and then here, this would be x to the 3n plus 1 over 3 times 4 dot dot dot, and I think it's pretty similar where it would be like 3n and then 3n plus 1. But again, you know, as long as you could get this, right, knowing that that's the pattern that you have, they don't really ask for the series that often, but, and I'll try, when I make up the test, I'll try to make sure I just ask for this portion of it for y1 and y2. So those are your solutions, y1 and y2 for this problem. These become very tedious. I'll try to do another example as we go along. But again, I think a lot of them are multiple choice, so as long as you get the pattern going, you should be all right.